Welcome to another edition of CMA 8th Grade Math Academy. If you're watching on YouTube, make sure to like, comment, and subscribe. Alright, so we're going to start off today with our learning goals like normal. So we've been working a lot with scientific notation, and that's going to continue today. So what are we learning? Students will perform operations, that's addition, subtraction, multiplication, and division, on numbers that are in scientific notation. Why are we doing this? Well, we already know how to write numbers in scientific notation, but we haven't really done any problems with them yet other than just comparing. So today, we'll learn how to do operations, which will give us the ability to use scientific notation numbers to solve real-world problems. And how will you know when you've been successful? When you are given a problem involving very large or very small numbers, you'll be able to perform operations on them and come up with an answer in scientific notation. Alright, so let's go ahead and jump in. If you're not already there, I would ask you to turn to page 62. That's M562. And on this page we have a getting started, which is kind of like a warm-up just to get us going. This is very similar to one that we completed last week, which was about the number of times you blink. Okay, so we're going to read that paragraph in the question as I read. As always, when I pause, I'm counting on you guys to fill in the blanks. Here we go. The average human has to 150 eyelashes on each lid and 70 to 80 eyelashes on each lid. Each person loses approximately 1 to 4 each day. Okay, that was our information. Here comes the question. If the weight of one is approximately, we've got a big decimal. You know I can't say point. Turn to your neighbor and tell them what that is without saying point. Ready to go? Hopefully you said 700 thousandths. That's how we say that. We don't say that point word and then a bunch of zeros. No, this is 700 thousandths. Okay, so 700 thousandths of a gram. That's what the approximate weight of one eyelash is. Okay, picking up from there again, read when I pause. Approximately how many of eyelashes have you lost in your life? All right, so kind of like last week, I'm not going to give you any hints. I'm not going to give you any more information than that. I just want you to try some things. And if you don't get an answer, that's okay, but you need to at least give an effort, try to figure out how many eyelashes you've lost in your life and approximately how much that would weigh in kilograms. Okay? All right, I'm going to give you 2 minutes. Ready, go. All right, so what we need to do first on this problem is we first need to convert what we know about the weight of an eyelash from grams into kilograms. So if you know anything about prefix, kilo means 1,000. So when we're talking about going from grams to kilograms, kilograms means 1,000 grams. So 1,000 grams converted to kilograms. Okay, so over here to the right, what we're going to do first is go from what we have, which is in grams, to kilograms. Okay, and we know that kilograms equals 1,000. Okay, so we know right now that one eyelash weighs 700,000th of a gram. And if we're going to convert that to kilograms, we have what we already have, okay? And our decimal place is right here. But if it's 1,000 more, that means we need to move our decimal place 3 places to the left because it's 1,000 more. So we need to go 1, 2, 3. That's where our new decimal place is going to be. And we got to fill in 0. So now it's going to be 1, 2, 3, 4, 5, 6, 7 zeros instead of 4 zeros. So that's how many kilograms one eyelash weighs. So not very much. Okay. Now, before we solve this problem, what I really want to do is turn that number into scientific notation. Okay. So if we're putting this in scientific notation, the kilograms, we know that our decimal place is way far to the left. So we're making a small number. So we know our exponent is going to be negative when we end up here. But if we count from here going 1, 2, 3, 4, 5, 6, 7, I can't stop there. I have to go here because I need my mantissa to be between 1 and 10, and 7 will make it between 1 and 10. So how many places did I go over? I went 1, 2, 3, 4, 5, 6, 7, 8 over. So when I rewrite this, now we know that 1 eyelash weighs 7 times 10 to the negative 8th kilogram. Okay? So now we have represented the weight of one eyelash in scientific notation. Okay? Now the other thing that I need in order to set this up is I'm going to convert the number of eyelashes also into scientific notation. So we have, what we know is that there was a total of 15,000 eyelashes lost, and all we're going to do is just convert that to scientific notation. When we know the decimal point is there, so if we move that decimal point 1, 2, 3, 4 places, it's going to be 1.5, which is between 1 and 10, so that works. So we have 1.5 times 10, and we move the decimal 1, 2, 3, 4 places, so to the 4th. And it's the positive 4th this time. The kilogram was such a small number, so it was a negative exponent, but this is a positive because it's a larger number. Okay? All right, so that was just to set it up, but it says we're calculating the total weight of all those eyelashes. Well, total sounds like we need to take the weight of each eyelash and add them all together, which would be a whole bunch of repeated addition, which we know is just multiplication. So what we're going to do is take our number of eyelashes. We're going to set up like this. Number of eyelashes that's going to be one number, and we're going to multiply that by the weight of each eyelash. Okay? So we know that the number of eyelashes in scientific notation is 1.5 times 10 to the fourth. And we know that the weight is 7 times 10 to the negative 8th power. And now we just need to multiply these together. But if you'll notice, okay, here we have 10 to the 4th power, and over here we have 10 to the negative 8th power. Now remember, last week we went over the rules of powers, and one of the rules was if you have the same base, you can add exponents. So here we have 10 to the 4th, and we have 10 to the negative 8th with the same base. So we can just take 10 to the 4th, 4 is our exponent, and add negative 8 because that's our other exponent. So when we add 4 and negative 8, we get negative 4. So when I come down here, part of my answer is going to be 10 to the negative 4th. Okay? Now, I still haven't taken care of the 1/2 and the 7, but I've taken care of the scientific notation part. Now I just need to deal with the mantissa. And well, each one is a number between 1 and 10, we know that, and they are basically just like coefficients on the 10 to whatever power it is. So we can just take 1.5 times 7 in this case. Well, 1.5 times 7 gives us 10.5. So we just took this times this and this times this and got an answer of 10.5 times 10 to the negative 4th. The only problem there is we have an answer, but it's not in scientific notation. So I'm going to kind of draw an arrow, say it's equal to. So the only thing that's wrong is we have 10.5. 10.5 is more than 10. We need something between 1 and 10. So what we have to do is move that decimal one place to the left. So it would become 1 and 5/100 times 10. And now when I write my exponent here, it was to the negative 4th, but we moved it 1 to the left, which means we actually add 1 here, and it becomes negative 3rd because we're making the number smaller. Okay? So our final answer is 1 and 5/100 times 10 to the negative 3rd. And again, don't forget labels. Labels are important, and it was kilograms, so I'm going to say kg for kilograms, and this is my answer. Okay? Now, the important part here was this step. Okay? Everything else we'd done before. We hadn't multiplied any scientific notation numbers before. But as you can tell, we know the power rule. We have similar bases of 10 and 10. So we just add the powers and then multiply the mantissas, the kind of like the coefficients. So 7 times 1/5 or 1.5 gives us 10.5. 10 to the 4th times 10 to the negative 8th is actually just 10 to the 4 minus 8, which gives us plus a negative 8, which is a negative 4. So our final answer, we just had to move the decimal over to make sure that was between 1 and 10, and then we had successfully multiplied two numbers in scientific notation. Okay, so that was the first one. Good job. All right, so on page 64, we have another question. And this time it says, an ecologist estimates that it takes approximately 196,000 pounds of buried plant matter to produce 1 gallon of gasoline. Some energy experts estimate that the United States consumes about 140 and 4/10 billion gallons of gasoline in 2015. Calculate the amount of buried plant matter needed to produce the amount of gasoline consumed in 2015. Write your answer in scientific notation. All right, so just like the question we had a little bit ago, we're going to need to put our information into scientific notation and then we can solve the problem. So we know that for 1 gallon of gas, it takes approximately 196,000 pounds of buried plant matter. So we need to convert that first into scientific notation. Well, we know that we need our mantissa to be between 1 and 10. The only way we can do that is if we make it 1 and 96 hundredths times 10. Now we need to figure out what our exponent is. Well, we move the decimal 1, 2, 3, 4, 5 places to get that. So our exponent should be a 5. And that is the amount of pounds of plant that it takes for 1 gallon. But the United States consumed way more than 1 gallon. They consumed 104 and 4/10 billion. Okay, so we need to convert that into scientific notation. But right now, the way that it's given is like this. Well, that just means that it's 140 billion, 400 million, and then the rest are zeros. We just fill in from there. Okay? But we want this in scientific notation. We don't want it as this huge number. Okay, so obviously we know, okay, our decimal point needs to go right here. Well, to get there, we had to take it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So when we write this in scientific notation, we know it's going to be 1 and 404 thousandths times 10 to the 11th power. So now I'm going to erase this down below so we have some space to work. Now we know, okay, well, we just need to multiply those to get our final answer. And just like we did on the previous question, we can just multiply our mantissas. Well, 1 and 96 hundredths times 1 and 404 thousandths is going to give us 2. And then we have 7, 5, 1, 8, 4. That's what we get when we put that in our calculator. But we don't really need all that, so I'm going to round to the hundredths place. Well, the hundredths place is a 1, so I don't need to bump up the 5 to a 6. So I'm just going to erase that. I'm just going to leave it as 2 and 75 hundredths. Now, that is times, we know it's times 10 to the something. We have a 10 to the 5th and a 10 to the 11th. Remember, our powers rule says that when we are multiplying by the same bases, we add our exponents. Well, 5 plus 11 is 16. So we know our final answer is 2 and 75 hundredths times 10 to the 16th power, and that is pounds of plant. And that is our final answer. So again, just kind of reviewing our steps. All we have to do is take our mantissa times mantissa, because it's multiplication that's going on here. And then we can apply the powers of multiplication rule and add our two exponents to get our final answer. All right, so let's go ahead and go to the next question. which is at the bottom of page 64. And we've got another question about these oil tankers. Okay, so it says an oil tanker is approximately 1,400 feet long. How far would 9,500 oil tankers span if they were placed end to end? And our question is approximate the length if we put all those oil tankers end to end, and we're going to write our answer in scientific notation. Okay, so again, let's gather what we know and put it into scientific notation. So we know that each oil tanker, so I'm going to say one tank is 1,400 feet long. And we know we're going to be multiplying that by the number of total tanks, which in this case is 9,500. And I'm going to go ahead and put these into scientific notation. So 1,400 or 1,400 put in scientific notation is going to give us 1 4 tenths times 10 to the third. And that is going to be multiplied by 9 5 tenths times 10 to the third. And once again, all we have to do, multiply our mantisses. Well, 1 4 tenths times 9 5 tenths is going to end up giving us 13 3 tenths times 10 to the what power? Well, we have 3 as our exponent and 3 is our other exponent, and we know we add those two exponents to get 6. So our answer is 13 3 tenths times 10 to the 6. But wait, we can't have a mantissa that's more than 10, and right now it's 13 3 tenths. That's more than 10. So we aren't quite done yet. We need to make an adjustment here. We need to make this decimal point move one place to the left. So it's really going to be 1 33/100 times 10, but it's not to the 6th anymore because we're moving that decimal over another place, so it's to the 7th power. And if we look back in our problem, we know we want to label it, and it's talking about a length, and it's talking about feet, so this is labeled in feet. And there is our answer for the total length if we place those tankers end to end. Okay. Question B says, what additional step is required to calculate the answer in question 3, part A, that was not required in question 2? You don't need to write anything for that, but I just wanted to draw your attention to that. Right here, on this last step, when we multiplied our mantissas, we got more than 10, so we had to do some extra work to make sure it was in scientific notation. So that's the step that they're talking about. So don't always assume after you multiply the mantissas that your answer is automatically in the correct scientific notation, because we know this one, the answer we got here in green, was not correct. We had to convert it to be a correct form of scientific notation. So just be on the lookout for that as we go through some of these problems. All right. So at the very bottom of that page, we have 4 problems that don't have words. It's just literally multiplication problems. And again, I'm going to go through one just to make sure we remember how to do this, but then I'm going to let you guys practice on the other 3. So if we look at A, we have a 3 and a 2. Those are our mantissas. And we know that all we need to do is multiply those. So 3 times 2 is 6. And we know that we have 10 to the 6th, 10 to the 5th. And we know that we always add our exponents when we have like bases that we're multiplying. So this is going to be 6 times 10 to the 11th power. And the 6 is already between 1 and 10, so we don't need to do anything with that. It's an okay mantissa, so this becomes our answer. Alright, so what I want you to do is work on B, C, and D. I'm going to give you 2 minutes to get those 3 done. Make sure your answer is in scientific notation, in the correct form of scientific notation. After 3 minutes, we're going to come back and check. Alright, ready, go. Okay, hopefully you found your answers for B, C, and D. We're going to quickly go over these. For B, you had 9 times 1, which is 9, times 10 to the 4th, plus 7th. Well, 4 plus 7 is 11. 9 is already an okay mantissa, so this is our final answer. Moving on to C. When you multiplied the mantissas for question C, you should have gotten 10 and 8/10, and you should have gotten times 10 to the 12th, but right away you should notice, oh, that's a little bit more than 10. I know it's really close, but it is more than 10, so we need to move that decimal place once to the left, so our new mantissa would become 1 8/100, and that would be times 10. We need to add one more to our exponent, so now it's the 13th power, and this would be the correct scientific notation form of that answer. Alright, and similarly on letter D, when you multiply those, you're going to get a number that's bigger than 10, because you're going to get 19 and 6/10 times 10. Now on this one, you had negative 6 plus 15, which gives you 9 for your exponent. And when you convert that, again, converting it into standard notation, you are going to get 1 96/100 times 10 to the 10th power. And that's what you should have come up with. Alright, so to this point, we have only done multiplication, but as you probably assumed, since our rule of powers of multiplication worked on standard or on scientific notation, the same is probably true for the powers rule of division. And that's what we're going to practice on this page. It works almost the exact same way, and that's why there's only 3 practice problems. So we're going to go through these now on page 67. Okay? You've got 6 times 10 to the 8th divided by 2 times 10 to the 3rd. Okay, and if we just first focus in on our bases, we have 10 to the 8th divided by 10 to the 3rd. And we know our powers rule of division tells us that we just need to subtract. So this is the same as 10 to the 8th minus the 3rd. Okay? So that takes care of that, but we still have this part right here, the mantisses. But if you look at that, that's just like a basic division problem. We have 6 divided by 2. Well, 6 divided by 2 is just going to give us 3. So we have 3 times 10 to the 8th minus 3. Well, 8 minus 3 is 5. So our final answer is 3 times 10 to the 5th power. And there we go. Okay. So I want you to do that same thing that I just did on letter A, but for letter B. I'm going to give you 1 minute. Ready, go. Alright, so hopefully you kind of singled out the mantisses and then also looked at the bases of 10 to the 5th and 10 to the 9th. So let's start there. So we had 10 to the 5th divided by 10 to the 9th. That's the same as saying 10 to the 5th minus 9. Okay. And then we had 9 divided by 3. Well, 9 divided by 3 is 3. So our final answer then becomes 3 times 10 to the negative 4th. And there's our answer. And letter C is very similar. We have 8 divided by 2, and then we have 10 to the negative 4th divided by 10 to the 3rd. Now, this one gets kind of tricky because we have a negative exponent. Okay? But the rule works the same way. So it's still just going to be 8 divided by 2 times 10 to the negative 4th minus 3. Well, negative 4 minus 3 is actually negative 7. So really what we have here is 4, because 8 divided by 2 is 4, times 10 to the negative 7th. So there you go. That's our answer. Now you know how to multiply and divide numbers that are in scientific notation. Just make sure you're converting your answer, if it's needed, into the correct scientific notation. Sometimes it's going to be more than 10, and you need to convert it back to the correct rules of writing scientific notation. All right, so you guys have accomplished what we needed to accomplish today. You can now multiply and divide numbers that are written in scientific notation. You are going to get a short homework assignment that is due tomorrow, and then tomorrow we will continue the video and it will cover adding and subtracting numbers in scientific notation. Thanks for working hard today, guys.